I am going to explain about Introduction to Transient Analysis. We know an electrical network is constructed from series and parallel combination of two terminal circuit elements. Circuit elements are broadly classified into two categories: active and passive circuit elements. As we know, active circuit elements are capable of supplying energy to the network. They are voltage source and current source. An element having no sources of energy is known as passive circuit elements. A passive circuit elements either absorb or store energy from sources. We can have three passive circuit elements. They are resistors, capacitors and inductors. Resistors absorb energy from source, and capacitors and inductors are energy storage elements. So in simple manner we can say that an electrical network is constructed from series and parallel combination of active and passive circuit elements. Whenever a network containing energy storage elements such as inductors or capacitors is switched from one condition to another condition, either by change in the applied voltage, that is source voltage or source current, or change in circuit elements, the response of current and voltages changes from one state to another state. The response may be voltage across a particular elements or current through that elements. So transient responses are present in an electrical network containing energy storage elements like inductors and capacitors when these elements are switched from one condition to another condition. Consider an inductor that is get energized with DC voltage suddenly. Assume initial current through the inductor is 0 during the time of switching. Before the circuit is getting closed, current through the inductor was 0. So whenever the switch is closed, current start flowing through the inductor within short spell. We know the voltage current relations in the case of inductor as VL is equal to L into di by dt. So as the current start flowing within short spell, dt is 0, near to 0. Here our inductor current changes from 0 to a new value. How to find out new value? I is equal to 1 by L integral V dt plus constant. So that constant determines the initial value, initial condition. This happens due to change in applied voltage source. Initially the applied voltage source was 0. There is no voltage source available across the inductor. Now due to switching, what happens? Some voltage, DC voltage suddenly occurs across the inductor. Current through the inductor changes from 0 to a new value. So due to application of these DC voltage, current through the inductor changes from one state to another state. The response in a network, that is voltage or current, due to the application of source, it may be voltage source or current source, for a long time is called steady state response. So under that condition, when a sudden change happen to the above circuit, what happens? The response in that network shifted to another steady state value. So some time is required to change from one state to another state. The time taken to change from initial steady state to final steady state is known as transient period. So what is steady state response? The response in a network due to application of a source for a long time is called steady state response. Mathematically we can represent it by like this. Response at t tend to infinity gives steady state response. So similarly, what is transient response? It is the response at t tends to 0, near to t tend to 0, immediately after switch is getting closed. So that response is known as steady state response. So total response contains two parts, transient response and steady state response. Transient response is the response at t tend to 0 plus, that is immediately after switch is getting closed. Steady state response is the response when t tends to infinity. Now let's consider this circuit. Initially the switch was in position 1. At t is equal to 0, the switch is placed in position 2. So whenever the switch was in position 1, voltage across the capacitor was the applied voltage V. So initial capacitor voltage Vc0 is equal to Y. Let it be the initial response, that is Y1. Initial conditions of the system or initial state of the system. As t tend to infinity, what happens immediately after switch is getting closed, the voltage across the capacitor is 0. Due to the charge available, initial voltage available in capacitor, it acts as the source and circulate current. Finally, it attains to a new value as t tend to infinity. You can say it as y2. So what is transient period? Time taken to change response from one initial steady state, that is y1 here, to another steady state value is known as transient period. Next, let's see why we are going to study transient analysis. Let's talk about power system. Generation, transmission and distribution of electrical power. So that section is usually termed as power system. In power system, we can have large number of generators having different capacities. When one of the big generator gets shut down, we need to know what are the protective measures we need to take. Similarly, due to lightning, over voltage may come into picture. It may damage some protective devices. In order to protect our power system equipments, we need to see what is the after effect of this over voltage. What is the after effect of generator shutdown? What is the after effect of under voltage coming into picture? What is the after effect of surge current, etc. So under these conditions, how system parameters changes with sudden occurrence of these type of things due to sudden change in circuit elements. So based on that one, we can fix the rating of protective devices, protective measures. Now let's see how to study this transient behavior of electrical system. So in order to simply study this transient behavior, we can use network along with symbol on and off switch. As seen here, when we are seeing this diagram, we can see that switch is going to close at t is equal to 0. Similarly, when we are seeing this switch, it is very easy to understand. At t is equal to 0, switch is getting open. That means in this case, initially the switch was in open condition. So after switching, the switch is get closed. In this case, before switching, the switch was in closed condition, and at t is equal to 0, the switch is getting opened. Basically, network analysis can be classified into two. One is steady state analysis and another one is transient analysis. In steady state analysis, normal voltage equation may come into picture. When we are dealing with transient analysis, in order to solve that network, we need to write differential equation governing the system. So during transient, network is associated with the differential equation. In order to obtain the response, that is transient response, we need to solve this differential equation governing the system. Also, while solving differential equation, it is possible to obtain some arbitrary constants. So based on initial conditions, we can determine these arbitrary constants. So by knowing the initial conditions, that helps to know the behavior of the elements at the instant of switching. At the instant of switching, what is the capacitor voltage? What is the initial value current through the inductor? So that information we can obtain from these initial conditions. To differentiate between the time immediately before switching and immediately after switching, we will use a sign minus and plus. For example, the current and voltage just before switching are denoted by I0 minus and V0 minus. Similarly, the condition just after switching are denoted by I0 plus and V0 plus. The response of the network at t tend to infinity is known as final response or steady state response. Similarly, the response at t tends to 0 plus is the transient response. Therefore, in order to obtain the steady state and final condition, we need to evaluate the network at t tends to infinity. Similarly, in order to obtain transient response, we need to evaluate the network at t tends to 0 plus. So, in short, for solving initial condition in electrical system or electrical network, the time periods are splitted or divided as just before switching, that is at t0 minus. The time varies from minus infinity to 0 minus 1. And second category is just after switching, that is at t is equal to 0 plus. Then 3 after switching, generally we can denote by t greater than 0. So these are the three divisions of time period which is used during transient analysis. So here we can conclude that if a network remains in one condition for a long time without any switching action, the network is said to be under steady state condition. Whenever sudden change occurs due to change in applied voltage or change in circuit elements associated with that circuit, transient may come into picture if the circuit contains energy storage elements. The response of the network at t tends to 0 plus immediately after switching. So that response is known as transient response. The response of the network as t tend to infinity, that is known as steady state response.